Hello everyone, my name is İlayda. Today, my group and I will present our project for statistics in engineering. Let's start. Our research question is, how does the average time studied per day and the number of courses taken by students affect their academic performance? This is an important question because students often wonder whether increasing daily study hours or changing their course load will improve their academic performance. So, the main objective of our study is to investigate the impact of two independent variables, daily study time and the number of courses on the dependent variable, which is a student's academic performance represented by their marks. To analyze this question, we use the dataset from Kaggle. This dataset includes information collected from students on how many courses they are taking, how many hours per day they study on average, and the marks they obtained. These three variables form the basis of our analysis, and in the right side, there is a picture of our dataset. It shows us the first 25 observations out of 100 of them. Since it only includes 100 students, it's a sample, not a population of all the students around the world. Our data is collected from a secondary source since it is obtained from Kaggle and not collected by us. And here are the summary statistics for our dataset, including standard deviation, mean, and median. Mean is a division of sum of the values and the total number of values. Median is the midpoint of the data. And finally, standard deviation is the average of squares of deviation of each value from the mean. These values help us understand the central tendencies and the spread of our data. We obtain the statistics using R, and you can see the R codes written for them in the pictures. We have used the built-in functions st, mean, and median to get the results.
Hello everyone, my name is INE2002. Today we are going to look at a few visualizations. First up is the histogram. The x-axis shows the marks and the y-axis shows how many students earn each range. Notice the peak is on the left and the bars gradually taper off to the right. That long right-hand tail tells us the distribution is positively or right-scaled. In right-scaled distribution, the mode sits at the peak on the left, the median is a bit to the right of the mode, and the mean is farthest to the right. Also, we check the normality with histogram. Normal or bell-shaped distribution, the mean, median, and the mode all lie so close together that they cover essentially the same area under the curve. Because of this right-scaleness, we can say that the data does not follow a normal distribution. Next is the box plot. This box plot about the time study. The wishes stretch from the minimum to the maximum mark time study. The box itself runs from the first quartile to the third quartile, and the vertical line inside shows the median. Here, first quartile is 2, third quartile is 6, and the median inside the box sits at 20 on the time study scale. Because of the box and wishes are roughly the same length on both sides of the median, the distribution looks nearly symmetric. Finally, let's talk about the scatter plot of study time versus mark. The independent variable on the x-axis is daily studying time. The dependent variable on the y-axis is the mark. The dot plot form a J shape. Short study sessions line up with low grades, while longer study times generally correspond to higher grades. In short, more study times tend to mean better results.
Hi everyone, my name is Ceren. First of all, I would like to talk about hypothesis testing. Hypothesis testing is a type of statistical analysis in which you put your assumptions about a population parameter to the test. It is used to estimate the relationship between two statistical variables. In hypothesis testing, there are three methods. These are traditional method, p-value method, and confidence interval method. Now I will give details about traditional method. A statistical hypothesis known as the null hypothesis or H0 asserts that a parameter and a certain value has no difference. A statistical hypothesis that asserts the presence of a difference between a parameter and a particular value is the alternative hypothesis, represented by H1. Now I would like to talk about tails. A one-tail test indicates that the null hypothesis should be rejected when the test value is in the critical region on one side of the mean. If mu is greater than k, it is right-tailed, and mu is less than k, it is left-tailed. In a two-tailed test, the null hypothesis should be rejected when the test value is either of the two critical regions. And this is an example of right-tail hypothesis. A researcher reports that the average number of courses of students taken is 6. A sample of 100 students has a mean number of courses is 5.290. Alpha is 0.01. Test claims that the number of courses which students take is different from 6. The standard deviation is 1.79. Our null hypothesis is mu is equal to 6, and our alternative hypothesis is mu is not equal to 6. Another topic I would like to talk about is ANOVA, a statistical test called analysis of variance. It is used to evaluate how the means of more than two groups differ from one another. Fundamentally, ANOVA enables to compare arithmetic means across the groups at the same time. You can be certain if the observed differences are the result of pure chance or if they represent real significant chance. For three groups, the F-test that can only show whether or not a difference exists amongst the three means, not where the difference lies. Other statistical tests, Sheffer test and the Tukey test, are used to find where is the difference exists. This code is an example of applying F-test in R. In this code, we compare the variances of number of courses and time study.
Hi, my name is Nisa. Now I'm going to talk about non-parametric statistics. These are also called distribution-free tests because they don't assume a normal distribution in the population. They are helpful when we are dealing with rankings or medians instead of means or standard deviations. Here is one common example is a single sign test. Single sign test checks if the median of our data is a certain number. For the number of courses, we are testing if the median is 5. Since many responses were close to 5 and the p-value was 0.752, we don't have strong evidence to suggest the median is different. Therefore, it's likely that the true median is indeed 5. To improve future studies, a larger and more representative sample from multiple colleges should be used. Additionally, including other factors such as stress levels and the use of learning tools could provide deeper insights. In summary, our study found a smaller positive link between academic success and the number of courses taken. We supported our findings with t-test and the confidence intervals. Overall, these results emphasize the importance of the time management and planning for students. These are our references. That's the end of our presentation. Thank you for your listening.